Okay, so a bit about our presenter this evening. Dr. Erik Beever is a research ecologist and research affiliate professor with the USGS Northern Rocky Mountains Science Center and Montana State University. Dr. Beever has performed field research on plants, soils, amphibians, birds, reptiles, fishes, and insects, as well as small, medium, and large mammals. His work has spanned a variety of ecosystems. He has published over 80 articles in diverse scientific journals and in numerous subdisciplines of biology. And he has edited 2 books. Crazy. Dr. Beever is interested in questions at the nexus of basic and applied science, especially those that also inform management and conservation efforts for species, communities, and ecosystems. Dr. Beever, I'm going to give it over to you now and turn off my video and monitor the chat.
Awesome. Thank you so much, Kristen. It's a pleasure and an honor to be chatting with you all. Let's see, I'm going to slideshow. Okay, can you all, I'm assuming that you guys can see this now?
Yes, it looks good.
Perfect. I just kind of thought I would give the first part of this revised title, What's Happening in the Mountains of Northern New Mexico. We, as Kristen alluded to, we're using the American pika as a model system to get at a lot of broader questions and understand what's happening in kind of some of our most strongly conserved and protected areas across northern New Mexico, and also, as you'll see, across the western U.S. and Western North America. So,
Erik, I hate to interrupt you, sorry, but your screen went away. Do you mind sharing again?
Oh, thank you.
I'm not sure what happened. No worries. It was up and it was gone.
Told me. Okay, so that's interesting. Yeah, okay.
It looks great. I don't know.
Okay.
Perfect.
Okay, great. Okay. Thank you. Please feel free to butt in again if I do that. Again, I don't know how I do that, but thank you. So before I go any further, so mainly what we're going to be digging into is both patterns and drivers of occupancy and abundance of a climate-sensitive species. From my co-authors there. Okay, so just to give you a roadmap for my talk this evening, I'm going to delve in a little bit to why would we be worried about mountains, what lessons they hold for us as both kind of for land and wildlife managers, for researchers, as well as for the broader citizenry. And I'm going to talk a little bit about kind of thinking about specific mechanisms and really trying to dig into questions regarding how and why species can cope with climate change. I will kind of give you a little bit more background on the American pika as a model organism to answer these broader questions. I will actually not talk very much about the Great Basin. I've worked there the longest. And so we have some kind of longer term understanding of the kinds of things that are happening, but I'm mostly going to be focusing tonight on what's going on with pikas across northern New Mexico. And yeah, kind of finish with that. So diving right in, mountain ecosystems are really these places there where there's chance events that biologists call vicariants, and local species that are locally adapted. And they are also constitute, because of their naturally connected habitats across various elevational and precipitation gradients, they are natural stages for climate adaptation. They constitute over 90% of the current portfolio of the most strongly conserved areas in the Western US, the nation, the continent, and the world. As I mentioned, they have these sharp gradients in both abiotic conditions that lead to sharp gradients in the biotic conditions. So even though they may have low diversity at any one place, across the mountainside, they have high beta diversity. So kind of pulling the camera back, they provide water for 2/3 of the world's fresh drinking water for 2/3 of the world's people through their capture of snow and subsequent release after the snow melts. They espouse and provide for quite a number of aesthetic and recreational values, both consumptive and non-consumptive. Given their relative isolation and climatic variability and harshness, compared to low elevations and valley bottoms, they're relatively poorly instrumented, and many of the things that are in them are poorly monitored. So, you're a wildlife biologist when you think that it's really interesting, cool that a species consumes its own feces. That's what coprophagy means. So it's especially important. This is most lagomorphs, the order in which pikas reside, do this. This allows them both to conserve water in water limited areas, but also to improve the nutrients that they can extract from their food. So they first excrete a cecal pellet, which they re-ingest, and then they excrete these fecal pellets. So, and I like to apply this, sometimes their territoriality. They achieve that both through chases and calls, but also by rubbing a gland on the side of their cheek, the apocrine gland, on the edges of their territory. So I get amused by thinking about high school students doing this behavior. They have a broad diversity of functions that their calls can serve. Everything from, and forgive my Northeastern accent, hey baby, how you doing? To, hi, look out! To, yo, scram, this is my spot. I was here first, get out of here. And others from offspring, mother communications, and a diversity of other things as well. Another thing that's interesting about them is that they're active year-round, which is pretty rare for montane species. They will typically either undergo, animals will undergo torpor or hibernation or estivation for non-mammal species, or they will kind of move downslope to summer range, especially for ungulates, the hoofed mammals. Interestingly, they inhabit only talus and talus-like areas. So this occurs at kind of spatially structured locations, as you can see here across Western North America. And on any given day, and especially in New Mexico, they do not move very far. So you have a lot of radiation and local adaptation and local diversification so even like several hundred meters is a really quite rare event for pikas. They'll not be moving that much. They can move larger distances, and especially as you go to the northern portion of their range, they can move farther, but those happen quite rarely and only in a small portion of the population. So the factors that really have undergirded our research, both in our research and other folks' research, even going back several decades, just because an area is isolated, folks have increasingly found that its components are not necessarily conserved. So all of our team were really interested in trying to identify patterns of both vulnerability and resilience. And as Kristen said, to as directly as possible to inform management and conservation options. And I will share some of those results with you today. And I wish that I had those slides a little bit better dialed in. I got those results pretty recently, as in like just a few hours ago. So I'm sorry, those aren't as nice looking. Our data were used back in 2011 by NOAA to help inform the Endangered Species Act decision on whether they should be listed. And and I think more broadly, they're really these montane ecosystems are frontiers for understanding of how systems work. Why I think that they're a good model to understand dynamics in mountain ecosystems more broadly is that they have this very broad geographic range that really encompasses a great diversity of climatic and other biotic and abiotic conditions. So it really gives us this broad tapestry to understand what's happening. We know from the paleontological record that their distribution has really waxed and waned over time in concert with glacial interglacial cycles. Researchers in a couple of places back in the late 1960s and early 1970s prevented them from behavioral thermoregulation, and those animals died within about 6 hours in each case. So if they can't shuttle above and below the talus, they can succumb to overheating stress. We don't know that that's super important in the wild because they're never kept in cages above the talus in natural settings. And more broadly, they're a model for a ton of ecological theory. They've been used as a system to understand a lot of broader dynamics about how animals move and live through time. In a practical sense, they're a great model as well. They can be really locally abundant, unlike a lot of mammal species. They have relatively stable population sizes, unlike things like arvicolines, what used to be called microteens, that can have these strong population cycles. And unlike almost most all mammals, they're very, very highly detectable, meaning if you go to a place that pikas are at, over 90% of the time, you will detect them because they make a ton of different calls, both to defend territories, to attract other members of the same species, and to defend their territory as well. And they also make these really obvious hay piles that they defend. And they have these very unique calls. And what's another interesting piece about them, as I kind of alluded to before, they have this easily defined habitat. Now with the advent of Google Earth, the Google imagery and other remotely sensed imagery, we're really able to now plan our survey locations while sitting in the office, which did not happen before. So this easily defined habitat, unique to pikas, is not changing over time, in the sense that the last time I checked, very few instances are folks wanting to put condominiums or houses on top of a talus slope. So this is a nice opportunity that we have, that losses are not complicated or confounded by habitat change, which is really, habitat loss is the biggest problem both for animals generally and for mammals specifically. And their distribution is changing, as indicated by both historical records going back to the 19th century, in the early 20th century in New Mexico, and then 28 years of recent data across the West. And our data span 6 years in New Mexico. So a good slice of time. So what the potential mechanisms of climate change working on mountain dwelling species that our teams have worked on most specifically are looking at food abundance or quality, such things as NDVI, the greenness of the vegetation, the species compositions, and particular species like raspberry and ocean spray and things like that. We're also looking at habitat fragmentation, and I'll show you, and as well as habitat isolation. So that's going to be part of our results here. And this actually is one of the first times that someone has done that for a broad scale. So I'm pretty excited about that. So we haven't looked at diseases, pests, and parasites, a pretty intensive piece that would really require handling of the animals that would not allow us to go all the way across northern New Mexico. We've looked at competitors and predators, more so competitors there, but physical conditions, everything from snow cover to stream flow to relative humidity to precipitation, and then to exceeding these narrow physiological tolerances. So what we use, and just getting into our methods a little bit here, what we use to say that pikas are currently occupying an area is if we see them, that tells us that they're there. If we hear them, which is the most common way that we detect pikas, and then if we see this active, fresh hay pile that has at least 10 different pieces of green vegetation. And what's neat about them is in the same survey, you can not only tell where pikas are, but where pikas used to be. And so here are pictures of those fecal pellets. I think the simplest way to think about them is they're kind of spherical, about 2 to 3 millimeters in diameter. And for comparison, here is one fecal pellet of a mountain cottontail, which is a little bit more compressed from top to bottom. But these things look like peppercorns or BBs. And really, pikas are the only species in these habitats that has these fecal pellets that look like this. The other piece that tells us that pikas used to be in a place is that these old hay piles can persist for years to decades. And these hay piles then are the center of their activity. They use these for a kind of central place foraging. They go out, they come back to the hay pile. Some of the techniques that we can use to understand what's going on over time. In some places, we have repeat photography from historical to current times. We have these historical field notes of collectors across New Mexico and the West that provided these amazing understanding of where they trapped and what they learned in terms of the natural history of pikas and other species up to over a century ago. And this also gives us understanding, as well as a repeat photography about tree line, legacies of different land uses, how has productivity changed over time, and conifer encroachment. Microclimate sensors, these things are kind of amazing. Now, each of them is a volume of 3 dimes. We put them in these simple PVC couplets, a cap and plug, after we've made it waterproof. And this can give us now data for 8 years, taking data every hour. So just a rich trove of information. So here's what those data look like. For example, in some places, and I will have to, I'll have to look after the questions for the specific things that we found in Bandelier. But in adjacent regions, these pika occupied sites rarely had temperatures within the talus that were above those temperatures, the black bulb temperatures at which pikas perished when they were kept in cages. So, less than like 59, 60 degrees Fahrenheit does it get down to where they actually live, those exact places where they live. The places where they've been lost more frequently had those temperatures down in those places that they live that were above those thresholds. What's interesting is that you can also see in the places where pikas remained at in this region adjacent to New Mexico, is that during the winter, there was up to like 8.5 months of across the sites there where they were snow covered. So it actually also, it's not as frequently very hot in the summer and also not as frequently very cold in the winter. This is because of that insulating snowpack cover. Whereas where they're gone, it also gets down to really cold temperatures there in the winter. So just to give you a sense of what so those fecal pellets that we collect from these places where pikas no longer are, we use a technique by dating them with radiocarbon dating to understand when was it that pikas were last in that place. And we're going to be getting a lot more sites from New Mexico. They've been submitted and we're going to be getting those results back relatively soon. But I just want to show you that in some cases, some of these, the dates that are suggested by the radiocarbon dating is that pikas last occupied a patch up to several centuries ago. Because of this, what's called the bomb curve, given use of given changes in the atmosphere, there's 2 different dates that can be found or estimated for a given fecal pellet. Just to give you a sense of where this work fits in. So what's kind of neat is that New Mexico has, you'll see a lot of neat lessons to provide. And then we can kind of compare and contrast those with what we found, and students that I've advised can have found. So this gives us an ability to really differentiate between pattern and exception. So focusing really now on what we have found in New Mexico. So first case is that there's, I guess the first take home message is there's really 4 what we've called lobes in which pikas exist. So this is the Jemez here. And then we have the areas near Santa Fe, the Pecos region that we have the Taos region, and then the northwestern lobe. And really, there were not very many records from here. So this has kind of been a neat ability to find pikas in this part. So each of these symbols here is a location that is currently occupied by pikas in our most recent survey. Then you have these orange squares that are talus patches in our most recent survey, where we found only old evidence and not current occupancy. And the red triangles are those at which we found no evidence whatsoever. And you'll notice in this one where they're all merged together that the red triangles exist kind of in those lower elevation, partly in those lower elevation margins and the drier margins of each of these regions, as well as in some of these in kind of the cores of those. But each of these lobes has all three states of occupancy: currently occupied, previously occupied, and then no evidence whatsoever. The last, no evidence whatsoever, either has never been occupied by pikas or was occupied so long ago that we can't find any evidence of them now. And each I guess, symbol signifies a single talus patch that is separated by at least 25 meters from all other patches. The closest edges are separated. So this is really, there's this unique dynamics within each patch. That's kind of one of the key assumptions about metapopulation dynamics that pikas have. So this is really cool. I think I'm really excited to be able to share this with you guys. So this is just understanding, looking at what are the climatic conditions at the places where pikas are currently, which is the green kind of histogram or area under the curve here. Orange is the sites at which pikas used to occur, and red is the area that pikas, we have no evidence of pikas at. So what's really interesting is that for chronic cold, we have some of the sites that look exactly like climatically in terms of what was the temperature all winter long from the PRISM data, which is gridded data from atmospheric data, assumed to be like 2 meters above the surface. So those sites look, at least with respect to that variable, they look exactly like the patches with no evidence at all, or with only old evidence. But there's also these quite a number of patches that are currently occupied that are much lower in terms of that winter long average temperature. So that gives us this mean condition where the green dots, this is the mean of the all of the pika occupied sites. Then the old evidence only sites or patches is in orange. This is the mean, and then the warmest over winter is those with no evidence whatsoever. So that's generally the case. The nicest conditions were for those that were climatically nicest for pikas were first. Intermediate were the ones that were only old occupancy, and the ones with no evidence whatsoever were the harshest. So you can see this kind of bimodality of what the conditions were at sites with pikas. And that's really interesting, especially as you'll see, given that we have these 4 distinct lobes that pikas are in New Mexico. And then we also have this for chronic heat. So what is the average temperature across all of summer? A lot of the sites that are currently occupied are really distinct from most of the old occupancy and no evidence sites, but some of them are right in the midst of those means for old and no evidence sites. We see that also with some of these other ones, but not as strongly as these cases. We also see it here in summer respite. So what is the minimum daily temperature during summer? Just some of the other variables show that even more strongly, spring precipitation. Some of these sites get a lot more, that are currently occupied, get a lot more precipitation during spring and annually, whereas some of them are right in the midst of the old evidence and no evidence sites. So quite interesting. So you can just see that growing season precipitation was a predictor for us, as was precipitation during the monsoon season and winter snowfall. And here's the kind of digging in to the three variables that were the strongest predictors of where pikas were in terms of no evidence at all, only old evidence or current occupancy. You can see now we've actually, so here are the kind of the composite results of where those three different classes of occupancy stand with respect to winter, all winter long. What's that average temperature? So now we're actually separating them by regions. The Southwest is the Jemez, Southeast is the Pecos Lobe near Santa Fe, Northwest is up to the north of the Jemez, and Northeast is the Taos Lobe. So what's interesting, what I want you to see here is for chronic cold, the Jemez Lobe, that it is dramatically different where pikas, at places where pikas are in the Jemez, is dramatically different than where they are in the Taos Lobe, much predicted to be much colder at the surface, pretty dramatically different than the Pecos Lobe as well as even the Northwest. We see that also in chronic heat. So what's that mean temperature across all of summer? The Southwest, the Jemez Lobe, is very different conditions than most of the other regions. So this is really exciting to me that either we have local adaptation, potentially behavioral and other kinds of phenotypic plasticity or flexibility and how they can handle these things, or we have differential existence of refugia, which I'll allude to later in the talk, among these regions. But and if it is a genetic difference between pikas here in the Jemez versus the other ones, and these are the three most important factors. So it's interesting that there's this very different ranges that they exist in across these very different lobes. If there are genetic differences, this suggests the possibility of using the genes from that Jemez lobe to help in climate adaptation elsewhere in the state and more broadly. So kind of getting into the results that we found for what is driving what's called ordinal occupancy. And ordinal occupancy uses all three of those categories. So no evidence at all, only old evidence, and then current occupancy. This is kind of the richest data on occupancy that we had. So we wanted to take advantage of that. And what's in here are the factors that were most important in those analyses across all of the different models. That chronic cold, so what is the temperature across all of winter? That was the strongest weight per model. And then the temperature across all of summer was in second. And then growing season precipitation was in all of the top models. So we used it in a lot of models. So that ended up reducing its rank in terms of weight per model. But I'm happy to answer questions more. I think this is a really important piece, this growing season precipitation for pikas in New Mexico. Our data where we have the most focused and strongest sampling in Bandelier really suggests that pikas occupancy and abundance are tracking that precipitation. And then sublethal heat, how frequently does it get above 20 degrees Celsius? That was the other strong predictor of whether pikas were in these three different categories of occupancy. And the best model out of all of them was the interaction of chronic cold and growing season precipitation. So if we just say, is the patch currently occupied or not? And we combine the patches that had no evidence with those that have only old evidence, we get a little bit different story. Similar, but the ranking of the variables changes a bit. So chronic heat, in this case, is the best. Precipitation during that monsoon season is second. and then growing season precipitation, sublethal heat, and then chronic cold are follow that. And then the best single model was the model that had the additive effects of both chronic heat and either growing season or monsoon precipitation. So just putting this in context, so we surveyed over the 6 years, we surveyed 594 patches. We had relatively few instances of recolonizations, although within Bandelier, we did have a good number of, across the 6 years we surveyed in Bandelier every year, we had a good number of times when there were recolonizations. Those recolonizations were outnumbered, both in Bandelier and across New Mexico by the situations when they were initially occupied, but our last survey had them unoccupied. But out of all of the patches, 55% of them no longer have pikas. Sorry, used to have pikas, but do not now have pikas. So they have the old evidence only. And so I wanted to just kind of contextualize that. The other piece that I wanted to share is that it's generally thought that pikas exist above 10,000 feet in New Mexico, right near Los Alamos, on the Santa Clara Pueblo's lands. We had evidence of pikas previously occupying a patch down to 2,300 meters. So that's around just over 7,500 feet elevation. So things were different in the past. And so we have this percentage of patches that are not occupied, that have experienced loss. And this contrasts with a study by Erb et al. 2011, in which they found only 3 to 6% of the patches that had historical records had been extirpated. And those were at generally higher latitudes and at much higher elevations, usually around 31 to 3,500 meters. So really pretty high. We see different values in these mainlands, and this is kind of what was really curious to us that really motivated the study in New Mexico, is that you can see in these mainlands of the Rockies, so here as well, the Rockies and the Sierra Nevada core, generally the rate of extirpations was quite low, but in these more isolated areas like the Great Basin down here, the rates of extirpation were much higher. So New Mexico is actually both. It's both a mainland, part of the Rocky Mountains, but it also is a trailing edge, which is where a lot of research, so this is essentially the southernmost edge of Pika's distribution. So they have really contrasting predictions. Because they're in this mainland, we thought they would do well. Because they're at this trailing edge, that we thought that would be not as good for them. So just getting into the drivers of density. I'm sorry, I don't have a graph for you to illustrate some of these, but the best predictor of whether how much density there is was what is the minimum daily temperature during the summertime. So do they get this ability to have this cooling off overnight or not? And that was the strongest predictor. And then we see this importance of growing season precipitation. And in terms of the single best model, and I wanted to note that the results and the strength of prediction were not as high for density as they were for whether the site was occupied or not. So density really gets at this as kind of an index of habitat quality, whereas the other ones, the occupancy get at, is the habitat suitable for a species or not? So you can see that there's actually quite a number of predictors that have at least some ability to give us insights into density, but those were much fewer in the occupancy. So this best model included additive effects of acute heat, summer respite. So what is that daily minimum temperature? Do they get a cool overnight, and growing season precipitation? And I just thought I would point out that we compared the ability of conditions in the current year to predict density. And this is only up through like the current year, so 0 years prior, is only conditions and climatic conditions up through like the 7th of June. So really short window. But even given that, those 0 year prior predictors, even though they were really short time periods, they were better able to tell us what was going on than the full year, that the full season that was indexing the mechanisms that we were thinking would be important for pikas from the year prior. So that in one sense, given how small these guys are, they're not like a big box of heat exchange and things where they can kind of continue to hold those effects across years, like an elk or a deer could do. They you can see a lot of zeros here in the top variables, top predictors. And I just kind of wanted to share some of the data from Bandelier. We saw kind of this, as I mentioned, this strong pattern of decline, both in numbers of individuals and numbers of patches that were occupied in the monument. And then we had a really strong winter and then spring 2019 precipitation. And we saw quite a bit of recovery in the monument. And I just wanted to kind of, given how close this is to Los Alamos and the peak viewing area, PEEC viewing area, not PEAK, note that actually the lowest elevation occurrences of pikas in this whole state of New Mexico are right in your backyard here in Bandelier. So really remarkable and interesting to see those patterns there. And this is just kind of a little bit of an understanding of what happens in terms of the conditions at this, what's called the rear edge or the trailing edge of a species distribution as compared to the leading edge of its distribution. So you have this at the rear edge, so the lowest elevations and the lowest in the northern hemisphere, the lowest latitudes. You have higher differentiation there, and you have regional diversity is highest there. The within population diversity is generally predicted to be very small in places like New Mexico, and the demographic stochasticity, how erratic some of the conditions are there, is pretty small there as compared with the leading edge. And the population age is generally predicted to be greatest and longest at places in the rear edge. And this is just an interesting piece from a different region that I thought I'd share with you, that there in that region, the Great Basin, in terms of understanding the factors that best predicted whether pikas persisted or not, up through 2000, there were two factors, the similar to in New Mexico, the June-July average temperatures, as well as the number of days below -5 degrees Celsius, created this really strong ability in a logistic regression to distinguish between sites that were retained pikas and those that did not. Interestingly, there were two sites that were extirpated that actually had values that were well within the range of climatic conditions of the sites that had retained pikas. So I would argue in terms of climate adaptation actions, there would be no value in, or it'd be less likely to be successful to put pikas back into these places here that are very different climatically than the places that remain. But these might be places where reintroductions would make more sense. And here's like the key piece, and I didn't have enough time to get you nicer graphs for this, so I apologize. So we actually did some post hoc analyses where we looked at how isolated is a given patch from the nearest 3 or the nearest 4 patches. And it turns out that by adding that in to the best, all of the best models that we found, best performing models, which in performance is assessed by understanding that simpler models are better, and how well does the model fit the data that we have from what we've observed out on the landscape. So, but adding in this patch isolation that improved models pretty dramatically for both occupancy and density. So the best model for whether the patch was currently occupied, previously occupied, or not occupied at all was, so that again included chronic cold, again included growing season precipitation, and the distance to these nearest patches. Let's see, for whether it was for binary occupancy, the best model was the chronic heat. So what was the average temperature during all of summer, and the monsoon precipitation. So how much rain was received during the monsoon season, as well as this distance nearest patches. For density, the key, we looked at a number of kind of things that related to management options, such as, is the site grazed or not? Is that what percentage of the patch perimeter is burned? So actually both of those improved model performance. So that was pretty cool. So that really suggests that there are opportunities there for affecting wildlife trajectories. So the best model was the additive effects of acute heat, summer respite, percent perimeter burned, and the distance to the nearest patches. I just wanted to kind of contextualize this with a couple more slides. So I just wanted to share with you something that's kind of, I think, visually pretty exciting, because this is work where we allowed what governs whether pikas are occupying a site or not. And this was really strongly informed by the species' particular life history. We used a number of multiple analytical frameworks. And our goal was to inform local scale conservation and management efforts, rather than assuming that what's happening up in Alberta and British Columbia is the same down in Mexico, New Mexico and Nevada, et cetera. So we allowed these things to vary across their range. And we got that, across New Mexico, this summer temperature, if we, that was the strongest predictor, accompanied with the whole range. And, for example, in the Uintas of Utah, winter precipitation was most important. So this doesn't necessarily give us the definitive answer, as you've seen with the more in-depth things that I've shown in the other slides, but this is just kind of neat. This is powerful that it gives managers an option of what kinds of climate adaptation actions to consider at their local scale. We've also done work elsewhere where we've used very fine resolution, so like 2 to 4 centimeters, where you can see individual leaves on a tree or even a shrub, to create this predictive model of pike occupancy, where we put cameras on the bottom of a plane and then fly over these locations, and we get absolute temperatures and color infrared imagery and then true color to be able to understand, just by having these data and knowing which patches were occupied or not. This allows us to create this predictive map of where we should look for more pikas. And just wanted to kind of show this schematic of where pikas, of conditions in mountains, going from the windward side to the leeward side, that there's this typical, as you go higher in elevation, temperatures go down. And then as you go from the windward to the leeward side, things become warmer and drier on that leeward side. So we had a student who we put sites across a number of really 64 drainages across 4 different mountain ranges. We looked at occupancy density and how much had it retracted. So in across the Continental Divide here in 4 different mountain ranges, we see putting in these things up and over the mountain. We can see that in individual drainages, those go from no evidence at all to only old evidence to currently occupied to at this site where the talus was really shallow, only old evidence. So just one quick look at those data across those quite a number of those watersheds. We see that there's been in each of those drainages, there's been in some cases no upslope migration of the bottom, the minimum elevation of occupancy. The gray is indicating current elevations that pikas occupy in that drainage, and the orange indicates what are the elevations that the species used to exist at. So in one drainage, there was no pikas whatsoever, and in others, there had been no extirpation whatsoever. And a big thing, I think, for New Mexico is the existence of these refugia. So that exist at different scales. Here's kind of different things that exist in terms of shading, north facing, these kind of the creeks, these cold air pools can be really important. So this, I think, is a big deal of what's going on in New Mexico. So here's just a landscape of Valles Caldera, just outside of Los Alamos, another part of New Mexico. And the final piece I wanted to share is in terms of what, kind of what are next steps. I just want to kind of share that the initial work, kind of really pulling the lens back, what has climate change research been about? The first step in that was to note that indeed the climate is changing in different ways, in different magnitudes across space and time. The next step at the most basic level is to understand which components of ecosystems are changing and what are those magnitudes in different locations. As I tried to mention earlier, understanding those how and why mechanisms by which things are changing is really important. And then with that knowledge, what do land and wildlife managers really do about this? In other words, asking what does the science suggest, given what we found, what things might be most valuable? And we are proposing some work to really get at some pragmatic and logistically feasible options to address this. So stay tuned for more news on that. But this kind of what the options and possible moves forward are depend on the guiding legislation of the land management agency. And I just want to note that across their range, pikas exhibit behavioral flexibility in some places, putting hay piles in standing dead trees and under fallen trees. We're not seeing this flexibility across New Mexico. Most of these things are happening up in Canada and in the greater Yellowstone ecosystem, but not in New Mexico. So pikas are really a cost-effective indicator for a lot of basic and especially applied questions. So the mechanisms that were involved really depended upon the response that we're looking at, kind of ordinal versus just occupied or not versus the density. And our work across all of the patches on the landscape provided a very different interpretation than the previous research that included a teeny bit, like I think 3 or 4 sites in New Mexico. So I think there's a different interpretation there. And I think the big picture is that species respond individualistically, and understanding these mechanisms, these how and why questions, is really critical to know how species can cope. And as I think I mentioned in quite a few different ways, species responses can vary across space and time. So a very incomplete list. Folks at Bandolier have been incredibly instrumental in this work, and so a huge shout out to them, and also like to thank those who came before me as well. So with that, I'd love to take questions.
All right. So currently we have no questions in the chat, but that does not mean we will not have any. Okay, we have a thanks, great presentation. It was very good. Thank you for sharing all of, like, basically a whole bunch of your research. It was pretty enlightening.
My pleasure. So really, really fun. I was telling Kristen earlier on, like areas in and around you guys and many corners of northern New Mexico have gotten into my heart. That's really appreciate a lot of those systems.
Yeah, it's pretty, I feel like I asked all my questions during during our run through. I
Right.
should have saved some. Well, it looks like no one has questions at the moment. Would you like me to play the video?
That sounds great.
Okay, cool. Do you want to give a little intro?
Sure, I would love to. Yeah. This is like a 70-second or 75-second video from Dr. Monica Moskal at the University of Washington. She's an expert in remote sensing. And I just wanted to share this with you because it really, it's a pretty high file size. So it may not come across super well if you don't have really fast connection. And there you go. But I guess why I think it's interesting is because it looks like an insect flying through trees. But what's amazing about this is this is based on actual data from LiDAR. So we're actually looking at, so these are actually not just depictions of trees, but these are those size of those trees, everything, the size of everything from the under canopy to the canopy is all a function of what's actually out on the landscape. So these techniques, in postdoc that I've had, we use these to look at a lot of questions trying to, so that we don't have to go out to every single patch, but to allow us to understand what's, get some insights from remotely sensing data. They have some pretty amazing power to see a lot of different places on the landscape with a given capture, but they also have some limitations.
Hmm.
So I just, to me, it's kind of a really an aha moment of what the capacities that we have are to understand natural systems now. So this is kind of like you just get this 3D view of flying through this forest at different, and when it becomes hazy, that's actually you're traveling through that tree canopy of that individual tree. So did I misremember how long it was?
No, we have 3 seconds left.
Oh yeah, okay, great. Yeah, excellent.
Okay, so we did have a couple questions that popped up. Okay, so can pikas be raised in captivity?
Excellent question. Kind of, I think the first knee-jerk reaction of pika researchers would be to say, oh, no, they can't. Because a lot of studies have reported that any individuals that were transported out of the talus died within a day, from a couple of different studies. But up in Canada, and then even in Colorado, several decades ago, at least one individual had captive pikas. And this was, I think, at 11,000 feet. So it's possible, but I think typically and the other reason that the knee-jerk reaction is that they're so easily stressed in a lot of contexts once they're handled, that can be a real challenge. So we're pretty cautious about the possibilities of moving them especially in places where that are kind of stressful, being drier or hotter. So, and I don't know if folks know this, but the place in pikas, which is the case for a lot of small mammals, how you get blood from them is from the optic nerve, which is behind the eyeball. So that's, you can imagine the degree of stress involved with moving your eyeball out of the way to get blood.
Yikes. Yes, it sounds very stressful. I don't like that at all. So a couple great jobs, and we have a question: does wilderness designation / human impact affect pikas populations?
Excellent question. So in my initial work, published in 2003, we found that wilderness designation did correlate with higher likelihood for pikas to remain occupied. And I think the real challenge that we're having kind of across New Mexico and across the West in understanding the importance of wilderness is that it's so often is conflated with climatic conditions. So typically the wilderness areas are at the highest elevations that are the coldest with the most snow and getting the most precipitation, whether it's growing season or monsoon or snow. So we don't have as clear of an understanding on that. My gut sense is that, and I guess anthropogenic impacts, let me talk about that first, beyond what I've said so far. So there's kind of equivocal understanding of what the effect of livestock raising is. A couple of studies have found, one of which an early study of mine, and then a study by another researcher in the Forest Service, found that livestock raising was problematic for pikas. And I think I have to double check the sign on ours to know whether the livestock raising promoted or inhibited the likelihood of occupancy. But oftentimes the livestock grazing is important only when the animals graze right up to the edge of the talus. So that isn't all in every case, that doesn't happen. And so that's kind of an important piece. Like sometimes because cows, for example, don't usually use the steepest slopes. So unless the situation is such that the cows can move right up to the edge, there's not going to be as much of an effect there. However, when there's a really small patch such that it has a high ratio of edge to area, I think those kinds of patches can have a higher likelihood of being affected by things like livestock grazing. And I mentioned the piece with the patch perimeter that's burned. I guess because they live in rock piles, they don't have as much in terms of research across the spectrum of folks. Humans generally don't have as much effect on pikas as they do on a lot of other species. So it's kind of a little bit of a feel-good story in that regard, that this is a species that's generally is relatively immune to the influence of humans. I will state obviously that places that they live in are typically more remote, and so the kinds of activities that you typically have are those where there's just hikers moving by. So we don't have any in the analyses that we've done that our teams and others have done, being more remote. Once you account for the differences in elevation and all the climate factors associated with that, remoteness doesn't seem to be a factor, or proximity to things like a road. So great question. Excellent.
Yeah, that was a great question. And then we have a couple of thank yous, and I know we're close to time, but I just had one question that did pop up, which is just a general behavior / life history question, which is, where do they hibernate? Like what is their winter story?
Their story in winter is they're rocking and rolling all winter long. That and so that's kind of an interesting piece. So that on the one hand, that's what allows them to be sensitive to what the conditions are during the winter. Like if there's no snow cover, they can, because they're not hibernating and really tucked away, they can be affected by a lack of snow cover. And because they create these hay piles, these massive hay piles, especially at higher elevations, they become really large, that they use as their insurance policy to get through that snowy season. And so they're active all year round, which, as I mentioned, is pretty rare for species that live up in the mountains. So they're moving around and eating that stash of hay pile that they made, and active all winter long. And because they have this really high metabolism, that means that they require a lot of forage on a daily and annual basis relative to other animals, their body size. So they eat a lot of, they make up to hundreds of foraging trips per day. So, but just one little fun fact before you all go, really, really interesting, this behavior of creating these hay piles. Folks back in the 1990s did this research, and as well as more recently out of the University of Wyoming, but the chemistry of what they eat immediately is dramatically different of the chemistry of the plants that they eat immediately is different from the chemistry of the things that they put in their hay piles. And the chemistry of what they eat out of their hay piles first is different from the chemistry of the plants that they leave in the hay pile for longer. They also use specific plants in their hay pile that are anti-mold and anti-mildew agents, which is super, super interesting to me. Like, these guys are really arranging the pantry for their overwinter storage. Pretty fascinating.
Yeah, that's wild. So neat. Okay, cool. Well, thank you again for joining us this evening and sharing your research and your knowledge about America pikas. And
I just want to say one more.
Yeah, go right ahead.
Yeah, if folks have any further questions, feel free to reach out to Kristen, or my email address is my first initial E as in egg, my last name Beever, Beever @usgs.gov. So feel free to reach out to me with any questions.
Awesome. Thank you for adding that. Okay. And thank you to everyone who tuned in this evening, who are still with us. Big thanks for all of your great questions. Please take a moment to fill out that survey. And like Erik said, please reach out if you have any follow-up questions after this. And if you're interested in tuning into more Peak programs, we do have an astronomy program this Friday. The sky is alive with the sound of music. I hope you can make that program. And yeah, thank you, everyone. Have a good evening. Thank you so much, Erik.
Absolutely. It was really fun.
Yeah, of course. We'll talk soon, I'm sure.
All right. Take good care, everyone.
Bye.